In today's lesson, we'll be learning how to write equations of quadratic relations. In our first example, we've been told that the graph of y equals x squared is stretched vertically by a factor of 3 and then translated 2 units to the left and 1 unit down. Furthermore, we want to sketch the parabola and write its equation. Before we do anything, let's identify the key pieces of information given. The graph is stretched vertically by a factor of 3. It is translated 2 units to the left and 1 unit down. Before interpreting this information, let's recall the vertex form of a quadratic relation, which is y equals a bracket x minus h bracket to the power of 2 plus k. We've been told that the parabola has been stretched vertically by a factor of 3. That detail corresponds to the a value. This would mean that a is equal to positive 3. Next, we're going to interpret this, which is translate 2 units to the left. That corresponds to the h value. And h in this situation would be positive 2. Remember, the h value is very counterintuitive. And last but not least, this detail, which says it is translated 1 unit down, that corresponds to the k value, and that means k is negative 1. We're going to take these pieces of information and we are going to write the equation of this newly transformed parabola. That would give us y is equal to 3x plus 2 squared minus 1. As you can see in this graph, the red parabola corresponds to the base parabola, which is y equals x to the power of 2. Whereas the blue parabola corresponds to the newly transformed parabola of y equals 3 bracket x plus 2 squared subtract 1. So, as you can see, it has been translated to the left by 2 units. It has been translated 1 unit down, and there appears to be a vertical stretch, which would make the parabola narrow. I know it's a little bit tricky to see these translations, but I want you to focus on the location of the vertex. And you can see more easily if it's being translated right or left or up and down. In our second example, we've been told that the graph of y equals x squared is reflected in the x-axis, compressed vertically by a factor of 1/2, and then translated 2 units upwards. Afterwards, we want to sketch the parabola and write its equation. Let's begin by identifying the key pieces of information. We're told that it is reflected in the x-axis. It is compressed vertically by a factor of 1/2, and then it is translated 2 units upwards. Before we interpret this information, let's recall the vertex form of a quadratic relation, which is y equals a x minus h squared plus k. Let's take a look at the information that says it is reflected in the x-axis. That would correspond to the a value. Moreover, compressed vertically by a factor of 1/2, that would also correspond to the a value. So the a value will be negative since it is reflected in the x-axis, and since it's compressed vertically by a factor of 1/2, you can just write negative 1/2. Our last piece of information, which states that it is translated 2 units upwards, corresponds to our value of k. Okay, so that means since our h value was not mentioned, we can just put a 0, and our k value happens to be positive 2. Let's take these values and place them into the vertex form of a quadratic relation. So a is going to be negative 1/2. H is 0. I'm just going to put a placeholder of 0 for now. And k is positive 2. It's pretty clear that you do not need this subtract 0, so I'm going to simplify our equation to just read 1/2 x to the power of 2 plus 2, and I forgot the negative sign, and there you go. In this graph, you'll see a red parabola, which is our base parabola of y equals x squared, and you'll see our blue parabola, which is our newly transformed parabola, and its equation is y equals negative 1/2 x squared plus 2. Now, let's just verify these properties. So, the value of a is negative 1/2. The negative means that it is reflected in the x-axis, which means it is opening downwards. In other words, it is frowning. The 1/2 corresponds to a vertical compression, which means the parabola should be more wide. And last but not least, the plus 2 corresponds to our k value, which means that our parabola is translated 2 units upwards. And again, if you have a little bit of a hard time visualizing that, remember to use the vertex coordinate to help you verify these properties. In our last example, we want to determine an equation for the parabola shown in the figure. I'm going to begin this question by briefly describing the parabola. Right off the bat, I can see that it is reflected in the x-axis. Which means that it is opening downwards. In other words, it is a frowning parabola. That should mean that the a value is negative. In other words, a is going to be less than 0. Next, I can't really see a vertical stretch or a compression, so I'm just going to put a little question mark beside that. And I want you to take a close look at the vertex. The vertex coordinate is 1, 5, which means it has been translated to the right by 1 unit. Which would mean the h value, remember this is counterintuitive, the h value is negative 1. And you can also see that it has been translated upwards by 5 units. So I'm going to write translate up 5 units. And that means the k value should be positive 5. This question is going to take a bit of work, so I'm going to need a little bit more space. You can do this on a separate piece of paper. I'm going to begin this question by writing the vertex form of a quadratic relation. Next, I'm going to put in the values of h and k that I observed based on the coordinates of the vertex. So that should give me this. Again, the negative 1 here means the parabola has been translated to the right by 1 unit, and the plus 5 means the parabola has been translated upwards by 5 units. At this point, we still have 3 variables, y, a, and x, but we can substitute a coordinate on this parabola and solve for a. And we are given a coordinate, and that coordinate is 0, 2. It is important that you do not use the vertex coordinate when you're subbing in a coordinate. So the y is 2. You can put that in brackets if you want. You don't really need that. The x is 0. Again, you can put that in brackets, but you don't need that. And at this point, it's just a matter of simplifying these numbers. If you can do this in one step, great. If not, go ahead and take your time. Negative 1 squared is negative 1 multiplied by itself, which is positive 1. And I'm going to need more space. And anything multiplied by 1 stays the same, so that's just a. And what you need to do here is you need to isolate a, so you need to subtract 5 from both sides. That cancels out. 2 subtract 5 is negative 3, which means a is negative 3. I'm just going to reverse this. So a is equal to negative 3. All right, let's recap at this point. I've just figured out the value of a, which is negative 3. And if you recall, we made the observation that the parabola was reflected in the x-axis. In other words, it was opening downwards or frowning. And we've just verified that. And we also know what the values of h and k are. We know it's negative 1 and positive 5. Therefore, we have enough information to write the equation of this parabola in vertex form. And I'm going to do that all the way over here. I'm going to write that as a therefore statement. Therefore, the equation of the parabola is y equals negative 3 bracket x minus 1 squared plus 5. And there you have it. The equation of the parabola in vertex form.